Now, we hear it all the time. Why do we use math? What's it good for? Well, one of the great things is that trigonometry helps make some of these reasons very apparent. So let's imagine a situation where I wanted to find the height of a building. I have some survey equipment, and this is how it works. A lot of trigonometry is involved. I'm able to measure the distance I am from the building, and that measurement is 300 feet. I don't know the height of the building. However, my survey equipment does tell me the angle between the horizon and the top of the building. And that angle is measured at 22 degrees. I also understand that my survey equipment is 5 feet off the ground. So given that information, I can use some of our trigonometric functions identities to determine something as difficult at one time, but now relatively simple as a height of an object, height of a building, height of a tree, or whatever it might be. So what we need to do in all these cases is, can we identify a right triangle within this system? Here I have a right triangle, building straight up, walkway over, and so I see a triangle. The distance on the bottom is 300. I don't know the height, but I have an angle. What angle will help me deal with an opposite and an adjacent type of information? Well, our tangent does. So the tangent of 22 degrees equals my opposite, in this case is an unknown height of A, over my adjacent, which is 300. From this, I can solve for what A will be. Multiply 300 by both sides, so I have 300 times the tangent of 22 degrees equals A. Use a black box to solve that. Check to see if it's in the correct mode to begin with. It wasn't, because I'm in degrees, so I better switch to degrees. In degrees, so 300 times the tangent of 22 equals 121, approximately 121.2 feet. Now, again, that's information helpful to us to solve the original problem, which was the height of the building. This is not the height of the building. That's only the height from the top of the survey equipment to the top of the building, this height of A. I have to add this additional 5 feet right here onto that answer. So plus 5 feet equals approximately 126.2 feet. And that's the height of the building using some of our trigonometry. So let's look at one last application concept here. This one adds a little bit of a different element that we did before, but it's important for us to know. Imagine a situation, have a height of a building known, the distance away from the building is known, and I'm curious about the angle of the ray of the sunlight is at this particular peak right there. Basically, what's this angle? How do we discover that? Well, let's think through the different trigonometric functions we have that allows us to take use of an angle and the sides opposite and adjacent to that. That's our tangent function again in this case. So I can develop an equation that says the tangent of theta is opposite over hypotenuse, or opposite over adjacent. So the tangent of theta is 21 over 25. How do I find theta in this particular case? How do I find the angle of inclination? Given that what we don't know is within the tangent function, we're going to have to use the calculator's inverse tangent idea. So as I'm calculated in, I'm going to hit inverse tangent. It's the key that's usually associated as a function key next to tangent. So my calculator, I'm going to hit the second button, tangent, so I get this little button that produces a tangent inverse, and then the parentheses start to form. Then I'm going to put in a 21 divided by a 25 and unparentheses. So what does that calculate to be? Calculates to be 40.03 degrees. So the angle where the sun is hitting me at this particular point, given this initial considerations, is 40.3 degrees. So it's kind of cool. We can find the degrees, or we can find different measurements within our applications if we're able to identify a right triangle and to put the pieces on that right triangle that we want to find. Because that's what trigonometry is. It's measurement with triangles. All right. Go out and have some fun.